Hello everyone, in this video I'm going to show you how to design a colpitts oscillator out of a common source amplifier. So this was the common source amplifier that we had done in the last video. You have the input and you have the low at the output. But as you know that the core idea of um, oscillator is to use the feedback from the output and then drive the input. So what we can do now is to start with this circuit, and we don't need any operating point analysis at this stage. So we are not going to change the bias condition. We only convert the circuit from amplifier to oscillator. So we delete the input and we also delete the output. So what you need to do now is to build a tank circuit. Yeah, by the way, let me, we need to make sure we are fully aware of the frequency response. So let's simulate the circuit first. Make sure we are aware of the bandwidth. So we simulate the circuit in AC domain, and we start from 100 to 0.5 gigahertz. So here we go. We check the circuit. We don't need this. We don't need this. And we are going to check the waveform. So from what I can see, the bandwidth is up to about almost 1 megahertz. Yeah, almost 1 megahertz. So in order to make an oscillator, the frequency should be anywhere larger, with the gain larger than 1. So you will be able to make the oscillator to oscillate. Say, I guess up to 20 megahertz. You need to spot for the 0 dB, and then you move up a little bit. And I think to play safe, I would design the oscillator to oscillate at any frequency below 10 megahertz. Okay, so we are going to start now. So we don't need the AC analysis anymore. And I'm going to delete the input and the output. So I'm going to design a operating the tank circuit for oscillation. So we need an inductor. and the midpoint should be connected to the ground. And there should be a large capacitance, very large, connecting from the output to the input. To the input tank circuit. And this is going to be say 10 micro. Normally 1 micro will work. So I will use one lamp. Say here is 110 say 100 nano. So the oscillation frequency according to here is 1 divided by 2 divided by pi divided by square root of half lambda 100 lambda. So it's about 22 megahertz. So it's still too large. I will make this slightly. I will make the frequency slightly lower. So perhaps 500 is better. Let's check 500. 110 megahertz. So I presume this should be safe enough. Okay. Now you are going to analyze the circuit from in transients analysis. So I will use, let me see the theory. So I will use 1 milli, and the starting time to save the data is 0. The time step can be 10 nano. So I hope this will work. And let's check this. So it works. And you will notice there's a lot of noise here. The voltage amplitude is also very large. And let's check the frequency first. The frequency is 8 megahertz, so it's quite okay. But the only problem is you had a lot of noise. Here is my suggestion. If you encounter this problem, you include some capacitor. So let me show you how to solve the problem. You let's say you add some capacitor here. You connect the capacitor to remove the noise in the supply voltage. So I will make it 1 peak, and here 10 peak. And then you simulate the circuit again. And not much different. Not much different. Yeah, another idea, yes. We can put a inductor here. The inductor here is 10 nano. And then you dampen the circuit a little bit using the capacitor, and I hope it will work. Yeah, it works slightly better. Yeah, less noise, less noise. Uh, so if you increase the capacitance here, now it's clearer now. You don't see any noise, so it's much clearer. So this is one way you can remove stabilize the oscillation frequency, but the frequency will not change. Still 8.8 megahertz, so it didn't change. So I presume my job is done. I've already shown you the way how to design a colpitts oscillator out of a common source amplifier. Uh, if you have any question, please leave your question to the comment sections. Anyway, thank you for your support. Bye bye.